Hey folks, Ms. Gosling here. In this video, you are going to be learning about transformers. By the end of the video, you'll be able to solve problems involving step-up and step-down transformers. And of course, you will also be able to tell me what step-up and step-down transformers are. So let's go ahead and get started. So, although transformers are in fact more than meets the eye, we are not talking about Optimus Prime and his friends. Instead, we're talking about those big green boxes you sometimes see on street corners or in other kind of places near roads where they're easily accessible but also not likely to get hit. So you can see in the picture on the right here an example of a transformer, so you can see what they look like. You've probably seen at least one of these before, if not more. Now, transformers are a really vital part of our electrical infrastructure because transformers can be used to change our alternating current from one PD, so one potential difference, to another. And because of that, they are really useful for transferring the electrical current that runs in our power lines to a amount of EMF, amount of potential difference that is useful for running different appliances in your house. So they make our electrical infrastructure a lot more versatile because we can very easily go from one kind of current to another. And from one magnitude of voltage to another, allowing our electrical infrastructure to serve a lot of different purposes. So for example, we could use the same electrical power plant to generate current for a light bulb and current for a massive particle accelerator, because we can change the amount of voltage being produced or being used by using a transformer. So now you know why transformers are useful. Let's go ahead and talk a little bit now about how they work. So an electrical transformer, when opened up, consists of three key parts. First, we have our primary coil, which I have drawn in red. And on the other side of our transformer, we have our secondary coil, drawn in blue. And you can see the way that I've labeled this on the diagram, you can tell that our primary current and primary voltage are different from our secondary current and secondary voltage. And finally, we can see on the diagram that the two coils are going to be connected by a core, which is almost always going to be made out of iron. So guys, what's essentially happening here is we are going to have an alternating current being supplied to our primary coil. And because that coil has a current running through it due to the alternating current, it is going to generate a magnetic field. And that magnetic field is going to change since our current is also changing. As a result, the magnetic field in the core is also going to change. And that changing magnetic field is going to generate a current in my secondary coil. And because the number of loops in my secondary coil is different from the number of loops in my primary coil, the magnitude of that current and the magnitude of that voltage are going to be different from the magnitude of my current and voltage in my primary coil. And in fact, because I know that d phi by dt is constant, so my change in flux over time is the same in the primary coil, the core, and the secondary coil, I can actually really easily relate the voltage in my primary coil, the voltage in my secondary coil, and the voltage in my secondary coil with the number of coils in each, the number of loops. So I can represent my voltage as either EMF with this curly E or as a capital V, that's the same thing. And I can actually figure out that my primary voltage divided by my secondary voltage is equal to the number of turns in my primary coil divided by the number of turns in my secondary coil. So let me go ahead and label all my variables. So let's go ahead and look at an example. A transformer steps down a main voltage from 120 volts to 5 volts for a tablet computer. The computer requires 1 watt of power to operate correctly. There are 2,300 turns on the primary coil of the transformer. Calculate the number of turns on the secondary coil. So let's go ahead and start by listing out what we know. So I know that my primary voltage is 120 volts and my secondary voltage is 5 volts. I also know that the number of turns in my primary coil is 2,300. And I know that I am trying to find the number of turns on my secondary coil, or NS. And we just went over the equation that relates them. So I know that VP over VS equals NP over NS, or NS is equal to NP times VS over VP. And I'm going to get that by multiplying both sides by NS and then dividing both sides by VP over VS. So what that is going to give me is that the number of turns in my secondary coil is equal to 2,300 times 5 over 120. Or, plugging that into a calculator, 96 turns. And there you have it, guys. I have used my equation to figure out the number of turns required to go from a primary voltage to a secondary voltage. So let's go ahead and talk about step-up and step-down transformers. So the really simple thing, they're actually very simply named. So a step-up transformer is a transformer that increases the voltage as we go from our secondary to our primary coil. And a step-down transformer decreases the voltage in our primary coil or in our secondary coil versus our primary coil. So if the number of turns in the secondary coil is greater than the primary coil, we have a step-up transformer, since our voltage is going to increase. And if the converse is true, if the opposite is true, so if NS is less than NP, then VS will be less than VP, and we will have a step-down transformer. So why does this all matter? Well, the real thing to know is that when we are looking at moving our currents around, so when we want to go from our power station to our house, we want to make sure that as little power as possible is lost in the wires, in the electrical wires connecting the two. And what we can actually find is that having a larger voltage in that wire is going to decrease the power that's lost. So, as a result, it's more efficient to transfer currents, to transfer electrical power at high voltages. But those high voltages are less useful in the home because we don't need that much power. In fact, having that much power could burn out things like light bulbs and much more quickly and can hurt our electronics as well. So as a result, we need to have a step-down transformer to turn it into a more useful amount of voltage. So, before I move on, I do just want to mention that the power is going to be conserved between our two currents. So between our two coils. So we're going to assume that no energy is lost, which is going to mean that I times V in the secondary coil is equal to I times, and that should be a V, not a P, in the secondary coil. So what that means is if I can figure out the voltage in my secondary coil, I can use that, and I know the current going into it, I can use that to figure out the voltage of my secondary coil. So let's go ahead and do an example that looks at that. So we're going to look at example 1 again, but this time we're going to calculate the current in the secondary cell. And to do that, I am going to need to use this piece of information here, the wattage of that cell, as well as the 5 volts. So I know that electrical power P is equal to current times voltage. And specifically, I'm looking at my secondary current and voltage, since I'm looking at the voltage and current in my tablet, or that secondary coil. So what that means is that the power required by the computer to run, 1.0 watts, is equal to the current running through that secondary coil that's powering the computer, times the voltage of the computer, which I know is 5 volts. So that means that my current, my secondary current, is 1 over 5, or 0.2 amps. So there you go. Simple as that. So let's go ahead and talk takeaways. First of all, transformers are used to change input voltage into appropriate output voltages, and they make our power grids more efficient. So there you have it, guys. You now know what transformers are, how they are more than meets the eye, and you know how to solve problems involving transformers. So go ahead, try solving some problems on your own. Best of luck, and happy solving.